Okay, hi guys. We are on the next lesson now, which is all about exponential equations. Now, we spent quite a lot of time last year working with exponential equations where we had x to the power of various things, or where we just had x in our exponent, which if you look at this first example is the case again. Now we are just incorporating e into that. All right, now it might seem a bit daunting at first, but what I do want you guys to remember is that we have specific, what's the word that I'm looking for? Methods of solving exponential equations. We're going to keep using those methods, getting everything that has the exponent on the one side and everything else on the other side. We are possibly going to have to do some factorizing, possibly going to have to identify some trinomials, factorize those, and then solve separate exponential equations. All of that stuff that we did in core last year, we're going to apply it to this, all right? There are no new methods. Now we just need to be aware of the fact that we are going to be working with e as well. But remember that e is a number. So it's not actually that new in a sense. What we are going to have to do that is new is we are more often than not going to have to change whichever exponential equation we started with or we are creating for ourselves. We're probably going to have to change those into log equations and then solve for x from there. All right, so for this first one, solve for x in the following equations. Number one, we have 2e to the 2x minus 1 minus 9 is equal to 0. All right, we're needing to solve for x, so we want to get that term that has the x in its exponent on its own on the one side and everything else on the other side. So I'm going to move that 9 to the other side. So I'm going to leave the 2e to the 2x minus 1 on the left-hand side, and that is then equal to 9. Now from there, I want just the e and the exponent on its own, so I'm going to divide by 2. All right, like so. Now from here, this is what I explained in the previous video, that sometimes you end up with an exponential equation where you can't solve it in the old way of writing both sides with the same base and then making the exponents equal. We see that we can't do that now. All right, it will take you forever to try and figure out what e to the power of what would give you 9 over 2. All right, so now we're going to use log, and we're going to use that as a tool to actually solve for this exponent. Now remember, when we're going from exponential form to log form, the exponent becomes the subject, so 2x minus 1 is equal to log base of the same base of the exponent. The base of the exponent becomes the base of the log. So log base e, remember, is ln of 9 over 2. All right. Now from here, you can calculate this if you want to, but then you're going to be working with decimals. So I would suggest that you actually keep writing your answer in terms of ln, and we're just going to solve for x. So minus 1 is going to become plus 1. So we're going to have 2x is equal to ln of 9 over 2 plus 1. And now to get x on its own, we need to divide that whole thing by 2. So x is going to be ln of 9 over 2 plus 1 over 2. Now this you can type into the calculator and we'll get an answer. All right, let's do that all together. So we have our fraction ln of 9 over 2 plus 1. It's important that you close the bracket after 9 over 2, otherwise it's going to use the plus 1 as a part of your log, which it actually isn't. All right, over 2, and that is equal to 1,25. There we go. Not too bad. Right, it's new that we're working with e, and it's new that we're writing it in log form and using ln specifically. Right, but apart from that, I don't think it's too bad. Okay, next one. I'm going to see if I can squeeze it in on the side here. Just move that up a bit. There we go. We have e to the x plus 2 minus e to the x minus 1 is equal to 4. All right, now we need to solve for x. Now what we have on the right-hand side here is we have two terms and both of these terms have an x in the exponent, right? Now, unfortunately, they're not like terms, so we can't add or subtract them. What we can do, and this is also something we did in grade 11 core, just with like normal numbers. I want to say normal number, just because we would have had, for example, 2 to the x plus 2 minus 2 to the x minus 1. All right. I think then all of you guys would have been able to do this question easily. Now we just have an e, which makes it look a little bit more scary, but we're going to do the same thing. We're going to break this up into e to the x times e squared minus e to the x times e to the negative 1 is equal to 4. Now we have e to the x as a common factor in those two terms. So we're going to take e to the x out as a common factor. We're going to be left with e squared minus 1 over e, or you can leave it as e to the negative 1. That's also fine. And that is equal to 4. Now what I want you guys to just keep in mind is that e represents a number. So what we have here in brackets, e squared minus 1 over e, this is actually a number. So I can take this whole bracket over to the other side and divide 4 by this bracket, and that will actually give me a number. All right, so that's what I'm going to do. E to the power of x is equal to 4 over this whole bracket. Now it's up to you whether you want to write e to the negative 1 or 1 over e. All right, both would be accepted. Now how are we going to solve for x? Now we're going to have to take this exponential form and rewrite it in log form. So the exponent becomes the subject. The base of the exponent becomes the base of the log. So log base e is ln. And then it's going to be ln of this whole thing. All right, so I'll just put it in brackets. You don't actually have to because it is just one term. Like so. Now all that's left is for us to type this into the calculator. So ln of, let's do our whole big fraction thing, 4 over e squared minus 1 over e. Let's see, isn't there just a normal e that doesn't have an exponent? Yes, actually there at the bottom. Just delete that. If you look at the times 10 to the x, that is the button that you would use if you just want to use e, right, instead of e squared or e to the 3 or whatever. So it's going to be alpha and then that button, right, and there we just have e, and then I'm just going to close my bracket there, and we have negative 0.56. There we go. That is the answer. Negative 0.56. Okay, so again, the same method that we did last year, where we have to take an exponent and split it up, and then factorize, and then solve for x from there. All right. Number 3. E to the power of 2x minus 20 e to the x plus 64 is equal to 0. Okay, now what we have here is actually a trinomial. I'm hoping that you guys can identify that. If we had something like this, if we had, let's do it in pink, if we had x squared minus 20x plus 64 is equal to 0. I think all of you would have identified that as a trinomial straight away, and you would have known to factorize. Now, let's just remember, and I know we did this in core last year, but it was like right towards the end of the exponents chapter. In a trinomial, you have something with an exponent of 2, and then you have that same variable with the exponent of 1. So the first term in your trinomial, the exponent is always double the exponent of the middle term, or the exponent of the variable in the middle term rather. All right, so we always have our exponents in a 2-to-1 ratio. Now I want you guys to notice that we have the same situation over here. 2x is double of x. All right, so we have that 2-to-1 ratio that we're talking about. Now if you didn't notice that, All right, I think you would have tried to do the following. I'm just going to do it in pink on the side. So you probably would have moved that 64 over to the other side. So you would have said e to the 2x minus 20 e to the x is equal to negative 64. All right, now you would have probably said, like we have at the top, we have two terms and there is an e to the x in both of them, because e to the 2x I can actually rewrite like this. All right, just see if you agree with me on that one. E to the x times e to the x is the same as e to the 2x, right? Because if you were to multiply these two together, you would add those exponents. Now, what are you going to try and do now? Now you're going to try and take out e to the x as a common factor. So you'll say e to the x, and then from here you're left with e to the x minus 20 is equal to negative 64. Now, what would you do from here? Now, I'm hoping none of you guys will try and do this, but now, are you going to say e to the x is negative 64 and this bracket is equal to negative 64? No, you cannot do that. Remember, you can only say that if the product of two things is equal to 0, that means that both of those factors will be equal to 0, or one or the other. But not if it's equal to a number other than 0. Okay, you would have to have this situation equal to 0, and in that case you would be able to split this up, say this is equal to 0, that is equal to 0, and solve for x separately. All right, in this case you can do that, but you will get stuck at this step. Right, there would be nothing that you could actually do from there. So the only thing that you can do here is to factorize this in the same way that you would factorize a trinomial. Now you can obviously look at it as product of 64, and the sum of those products must give you negative 20, but we have the silver calculator, so I just want to show you guys once and for all how to use your silver calculator to help you solve one of these equations. All right, now remember, if you were to factorize here, what would you put in brackets? Would you put an e to the 2x in brackets, or would you put an e to the x in brackets? Right, remember when you're factorizing a trinomial, what goes in brackets is always, if we had this, for example, you wouldn't put x squared and x squared, because if you multiply x squared by x squared, you get x to the 4. Right, so that wouldn't work. You would put an x and an x. So it would be the same type of term as you have as your middle term in your trinomial. So what we're going to do here, we're going to solve, and whatever we're going to have in our brackets will be e to the x and e to the x. All right, so the middle term, that variable is actually what's going to go in our brackets. Now, first I'm going to show you guys using this trinomial here. You're going to say mode, you're going to go to 5, which is equation, and now you need to select the type of equation that you're solving. We're solving what's the word? Quadratic, quadratic equation. So we're going to go to ax squared, so 3. Now it's giving you spots to fill in your a value, your b value, and your c value. Your a value here is 1, then you press equals. Your b value is negative 20, then you press equals, and your c value is 64, then you press equals. Press equals again. It will give you the first x value, all right? They're saying here that x is 16. Or if you press equals again, it will give you the next x value, x equals 4. And that is what I want you guys to do from now on when you are solving a quadratic equation, or even a cubic equation for that matter, in AP. All right, you don't have to write the quadratic formula down and show your substitution. You do have to do that in core though. You don't have to show your brackets. You do have to show your brackets in core. All right, so if this had been a core question, before you write your answers down, you would have to say x minus 16, x minus 4 equals 0. So you would essentially, you could kind of cheat using the silver calculator. I'm not saying that. No one said that. It's just, yeah, I'm thinking out loud. So you could do that, and then you would have x equals 16, x equals 4. Now, in order to get those two answers from your brackets, when the product of those brackets is equal to 0, it would have to be x minus 16 and x minus 4. So you would have to write this step in before you write your answers. In AP, though, they do allow you to just go straight to the answer. All right, so we're now going to use this. We've already typed these values in, all right, because our value here, our A value was 1, our B value was negative 20, and our C value was 64. So what do we get from here? E to the x is 16, or e to the x is equal to 4 when you use the calculator and you get your two values. All right, but in order to do that, you just had to identify the fact that it is a trinomial. All right, and you also had to identify that these terms were actually in the correct order, because they could try and trick you and they could put the x term in front and the 2x term in the middle, and just, I mean, you might make that mistake there and just think that the first term is the A value, the second term is the B. It's not necessarily always like that. The variable or the number, whatever that has the exponent that is double the other one, the double exponent needs to go first. All right, that's always your first term. So now here we have two separate exponential equations, which we can now easily solve just by writing them in log form. So we have e to the x equals 16. So x is going to be ln of 16, which is, let's put this back in normal mode, ln 16 is 2,77. Or in the other one, x is ln of 4, which is 1,39. Okay, and that is basically it. That is how you would solve these equations. Right. In the answer series, what they do is they let e to the x be equal to k, all right? But I don't really think you need to do that. I think it's straightforward enough to just identify this as a trinomial. And then the other trick is to know what your values will be equal to, all right? Because here, when we solve for x, or when we solve this equation, the answers, the trinomial answers were the x answers. Right, when we did the factorization. Here, the trinomial answers, the factorization answers are not equal to x, it's actually equal to e to the x. All right, so you needed to identify that. Again, the reason for that is because the type of equation that we have is an e to the 2x minus 20e to the x. All right, when you factorize, you always get your middle term variable is what is equal to those values. Right. I'll give you some examples of these to do, or some questions. So it's exercise 14.3 on page 149. Then I'm going to attach another example. It's an example of an application type question. It's basically a word question that involves logs and e. So I will add in that example, and then you're going to have to do exercise 14.4 as well, please. And those are very important. They love asking questions like these ones in your final matric exam, because it's using logs, it's using e's, but it's also actually not e's, e, but it's also actually testing your interpretation of mathematical, of a scenario. So it's very important. There are 3 questions there. I would like you guys to do those 3 as well. All right. Thank you so much.